Hello everyone! Today we're going to be doing a deep dive into 2D grass. What you see currently is a procedurally generating field created utilizing cellular automata, dynamic regrowth over time, spawn iteration based color distortion, and a variety of self-drawn sprites. Now the grass object prefab that we're going to be spawning is essentially just a custom tile. I'm making each tile have 3 sprites rather than 1 with a set Y value and slightly randomized X value for a more diverse visual. Since we want our grass to be dynamic, it's going to change and influence its surrounding tiles over time. I drew up a few starter sprites that were roughly 128 by 128 in sizing, and then I brought them over into Unity. The grass object prefab has a top, middle, and bottom object, just so they each could have their own sprite renderer. The associated grass object script just has references to these positions and renderers, and from a list of sprites, it randomizes which 3 it has from that sheet I drew earlier in its initial spawn function. Once that's all said and done, we have to switch over and create the actual spawn manager for our grass fields. Since the grass object is once again just essentially a custom tile, we're going to be using a reference tile map that I already laid out as a sort of boundary box in which the grass spawns onto. I've been working with tile maps for a while, so I have some helper functions already set up, but basically what's going on here is that the tile map reference has a list of values with info about the associated 2D array that represents the X and Y grid of the map. We're going to be iterating through the entirety of the tile map's array and spawning grass in the same position as every valid tile. It's important to check that the tile position actually exists, as well as compressing the tile map bounds to prevent incorrect spawns. I also finagled with the sprite rendering position a bit too while I was at it, which gives a really nice and subtle look to mimic grass being behind and in front of the player. Now that we have a way to get the spawn boundaries, we can have a bit more control over the pattern of our grass fields. I'm going to be using cellular automata for this, which if you're unfamiliar with is a relatively simple way to generate a grid of controlled noise by enforcing a rule set. Each tile has to follow that rule set, and then that determines whether they die, live, or multiply. I had some procedural generation projects in the works, so I just pulled my basic script from there, but I still had to do a bit of math to properly line up the new 2D array I was going to be calculating, since it was going to take into account the already existing tile map data. I can do a deep dive into cellular automata specifically if anyone is interested, but the basics are that given a width, height, and fill percentage, the cellular automata will spit out a filtered 2D array that's then translated to the positions that the grass objects will spawn. Step count in the step function is going to refer to each time the rule set is applied onto the array, which gets into the procedural generation part of things since the array and subsequently the landscape are constantly changing. As you can see here, you end up with a pretty nice spawn shape off the bat based off of the initial fill percentage you set, but this is kind of boring and grass is much more complex than that, so let's go a little further. First off, we're going to put the procedural into this procedural generation by properly utilizing the step function. What are you doing, step function? Spawning grass. In order to implement this, we need to convert our grass spawner into a time agent, which is a script that's subscribed to a clock-like manager that controls all objects that change over time. This means it needs a tick function rather than its update function, which will be called based off of a custom set time interval that the clock manager controls. So now we have growth over time. Fantastic. We're making moves. I added some debug variables like current fill percent and step count in order to keep track of the growth during runtime, which helped me out with the math that's coming up later. And now that we have the potential for growth over time, it's time to take into consideration how grass actually grows. Now, if you want to be real technical, then it depends on the exact species, but in general, grass is relatively patchy, so I added another variable to track the percentage change of additional spawn even when the proper conditions are met. I also fixed up my debug data at this point to keep track of the fill percentage, the amount of filled cells, and the amount of removed cells each wave, which are the tiles that get removed by the additional spawn chance. We're getting so much closer, but at this point my spawn grass functionality was horribly structured, so I took a quick break to resort that out, as it's important that code is readable. A tiny bit more cleanup, and I ended up with a spawn pattern that I was quite happy with for now. Look at them go. They're doing great. With spawn patterns out of the way, we can shift gears to more visual enhancements. First off, let's talk animation. My original goal was to animate a wind wave throughout the field and a small rustle animation when any creature or the player walks on or through the grass tiles, but I ended up scrapping the wind intention as large-scale animation of tiny objects can be quite expensive performance-wise even if they're simple clips. The rustle animation upon interaction was pretty cheap and simple with implementation, however, so I got that in through the use of an animator, a simple clip, and a trigger that's activated upon the object's collider colliding with something else. It made for a nice little visual swish that I quite enjoy. Last up on the list is spawn iteration-based color distortion. Now what do I mean by that? Let me explain while I drop a few new sprites in the background. What we're going to be doing next is implementing some color distortion onto our sprites to create sort of a gradient look within the fields. Grass, and a lot of other plants to be fair, change colors as they pass through different stages of growth. We're going to be simulating this by changing the color each spawn wave has. Technically the color could be altered even further to change per plant based on time, but I ended up having just one color for simplicity reasons. Now that those new sprites are in and we're hopefully on the same page, let's look at the actual implementation. I set the sprite color and code using Unity's gradient object, which is a little annoying to be fair, but once you get the understanding down of the parameter it takes, it's not that bad. For a gradient, you have to define an array of color keys and of alpha keys. These keys are defined by passing in the value and the time of the key in relation to the whole gradient. So if you wanted a red, green, and blue gradient, you would first pass in red, then 0.25f or something for the second parameter, and then green would be like 0.5f for the time, and so on. If you're defining custom colors like I did, and you want to use 1 to 255 for the values, make sure the color is defined as a new color 32 since color is 0 to 1 and color 32 is 0 to 255. That's true for the alpha value as well. Full opacity is 255, not 1. Not that I made the mistake at all. I spent a decent chunk of time just picking colors, but the outcome is quite nice in my opinion. So now after everything we've gone through, we have a dynamic, procedurally generated field utilizing cellular automata, color distortion, and animation. Procedurally generated stuff is always pretty satisfying to watch change over time, and small value changes can do a lot with the visual outcomes. From here on, there are still other aspects that we could add to our grass, such as being able to harvest it, the plants actually dying, more in-depth coloration, etc. But for now I'm content with it. I've also added a brief clip here, without the player and UI just for easier viewing of the environment. Thanks for watching. Any and all support and feedback is greatly appreciated. I would also love to hear if anyone wanted to see anything specific next, such as that cellular automata dive I mentioned earlier, as I'm 100% open to doing tutorials. Beyond that, bye for now. Stay sexy, gamers.